It turns out if a number is a product of two relatively prime numbers, then you can use the test for both the factors. If it passes both those tests, then it's divisible by that larger number. We don't need to know that or understand that, but that gives us the test for this video. For example, since 6 is 2 times 3, a natural number is divisible by 6 if and only if it is divisible by 2 and divisible by 3. Okay. A natural number is divisible by 6 if and only if it's divisible by 2 and it's divisible by 3. That means to be divisible by 2, remember that it's even, or the last digit's divisible by 2. And divisible by 3 means the sum of all the digits is divisible by 3. So let's check out some examples. Is 23,420,178 divisible by 6? Well, it has the opportunity to be, because it's certainly divisible by 2, because 2 divides 8, so 2 divides 23,420,178. So now I need to check to see if 3 divides it. To check 3, we take 2 plus 3 plus 4 plus 2 plus 0 plus 1 plus 7 plus 8. This is 5, 9, 11, 11, 12, 19, 27. So since 3 divides 27, 3 divides 23,420,178. And since 2 divides it and 3 divides it, 6 divides 23,420,178. So since both 2 and 3 divide this number, so does 6. Let's check our next one. So is 34,231,397 divisible by 6? No. 2 does not divide 7, so 2 does not divide 34,231,397, so 6 does not divide it. Okay, 6 does not divide 34,231,397 because 2 didn't. We don't need to check 3. If it fails the test for either one, it is not divisible by 6. Is 122 divisible by 6? Well, it's even. However, 1 plus 2 plus 2 is 5. 3 does not divide 5, so 3 does not divide 122, so neither does 6. 6 does not divide 122 because it fails one of those tests. All right, let's check out our next divisibility test. So we have 6. I just want to circle back momentarily to 10, a natural number. Oops, I like to write this page in black. A natural number is divisible by 10 if and only if it is divisible by 2 and divisible by 5. But if we think about what that means, remember a number is divisible by 2 if it's even. So if it ends with 0, 2, 4, 6, or 8. A number is divisible by 5 if it ended with 5 or 0. So if it has to end in both 0, 2, 4, 6, or 8, and 0, or 5, the only overlap there is it ends in 0. So to pass both of these tests, it has to end in 0, which is the test that we had before, but it works with this same idea, because 2 times 5 is 10, 2 and 5 are relatively prime. That gives us the test for 10. So here I have 32,332,170. It's divisible by 10 because it's even. It also ends in a 0, passing the test for 5. So again, 10 divides 32,332,170 because it passes both the tests for 2 and 5. Similarly, 10 does not divide this number, 42,221,325, because although it's divisible by 5, it is not even. So since it doesn't pass the test for 2, 10 does not divide 42,221,325. Rather, since 42,221,325 doesn't pass the test for 2, that's why 10 doesn't divide it. All right, let's get our last test here. This is for the number 12. A natural number is divisible by 12 if and only if it is divisible by 4 and divisible by 3. Okay, so to be divisible by 12, you have to be divisible by both 4 and by 3. Recall the test for 4, it's the last 2 digits of the number make up a number divisible by 4, and the test for 3, the sum of the digits is divisible by 3. So let's check an example. Is 15,950,316 divisible by 12? Well, let's check it out. So let's do the test for 4. So 4 divides 16. So 4 divides this number. Okay, we just have to check those last 2 digits for 4. Now to check for 3, we need to take 1 plus 5 plus 9 plus 5 plus 0 plus 3 plus 1 plus 6. 1 and 5 is 6, 15, 20, 20, 23, 24, 30. So since the sum here is 30, and 30 is divisible by 3, so 3 divides 30, so 3 divides 15,950,316. That gets me to my final conclusion here. Since 4 divides this number, and 3 divides this number, 12 divides this number. So 12 divides 15,950,316. Let's check another number. Is 318 divisible by 12? I can see pretty quickly 318 is divisible by 3. But what about 4? To check 4, I need to know, does 4 divide 18? And it doesn't. 4 does not divide 18. So 4 does not divide 318. So 12 does not divide 318. Okay, and I shouldn't have even checked for 3, because if I checked for 4, I would see right away 4 does not divide it because it doesn't go into 18. Is 316 divisible by 12? This time we meet the 4, because 16 is divisible by 4, but do I meet the 3? 3 plus 1 plus 6 is going to be 10, so 3 does not divide this number. So neither does 12. 12 does not divide 316. All right, there are the new tests we have. 6 works only if it's divisible by both 2 and 3. 10 is still the same, ends with a 0, but coming from the test for 2 and 5. And then 12, it is divisible by 12 if and only if it's divisible by both 3 and 4.